I'm Anil Kumar, and in this video we'll share a few tips which will help you solve some questions based on complex numbers. So we'll start with very basic so that students who are appearing for the new format of SAT can also benefit. So let's talk about complex numbers. We had been working with equations like quadratic equations like x squared plus 4 equals to 0. Now whenever you get such an equation, you say that this equation does not have a solution, especially when we say x belongs to real numbers, right? Because when you rearrange, you get x squared equals to minus 4, and we know that in the domain of real numbers, square is always positive. We say square is always positive, right? So we say square is always positive, so no solution in domain of real numbers, right? So that is real numbers. Let's say like this. Okay, so that is what we had always said till now. But really speaking, when we had been working with such equations so many times, we have to find a solution. So working around with this, we say, well, now let's have a new number which will be known as I or iota, right? So we say let square of this number be negative 1, right? So this is what is introduced. So we say if square of this number is negative 1, then the value of I is square root of negative 1, right? So this number is being referred to as I, right? So this is called pure imaginary number. So it's not a real number, it's a pure imaginary number. Right, so we also say iota. Okay, so that's the introduction to the complex number, right? So now once we have this, we really have a solution to this. So we can now solve the equation further. We say x squared equals to minus 4, right? So we can now say x is equals to plus or minus square root of minus 4, right? So now we are talking about x belongs to set of complex numbers, which is written by the letter C, capital, right? Now since we know that this iota is minus 1 square root, for example, this could be written as plus minus square root of minus 1 times square root of 4. Is that okay? Now we know square root of minus 1 is our imaginary part I, so I could write this value x as equals to plus minus I, and square root of 4 is 2, right? So we get I2. Now it is customary to always write the numbers first, right? So we'll write x equals to plus minus 2i. So that becomes the solution for the given quadratic equation. Is that okay? So till now we were saying if b squared minus 4ac is less than 0, then there is no solution. But if we are talking about complex numbers, then we'll always have solution. Is that okay? So this iota I is actually equals to square root of minus 1. So that's kind of base which you should know about. Now one more important thing is what happens when we multiply two complex numbers. So what I will do here is I'll give an example where we are multiplying two complex numbers, and we'll talk about conjugate numbers now. Let's also introduce a concept of conjugate complex numbers. Now these are important things to know when you go for SAT test, okay? So if I say that a number is a plus bi, let me write I first and b second. So this is one number. In that case, this is a complex number where a is the real part and this ib or bi is your complex part. Now the conjugate for this is a minus bi. I'm writing ib, right? So normally when you write like this, you normally write I first, right? So that is the complex numbers conjugate, right? So conjugate, like you do in square roots, we always reverse this sign to get a conjugate. Now let us see what is their product. So we'll also see now what is the product of conjugates. So we'll just multiply these two and expand. So we have a plus ib times a minus ib. I is iota. So when you multiply this, in that case, we'll multiply with a first. So we get a squared, then minus iab. Then with I, we get plus iab. And when you multiply these two, we get minus I squared b squared. Is that okay? Minus I squared b squared. Now minus iab and plus iab cancel out. So basically you are left with a squared and you got minus I squared. What is I squared? I squared is -1. So we have minus of -1 times b squared. And that gives us a squared plus b squared. Do you see that? So a squared plus b squared is the product of the conjugates in complex numbers, correct? So a squared plus b squared is the product of conjugates. So that is very important thing to understand, right? So this is another thing. Now we will see how to separate the complex and real parts. So we'll write how to separate complex and real parts when we write complex numbers in rational form. So let's look into complex rational form. Right, so let me write down an example. Let's say we have here 2 plus 5i divided by, let's say, 3 minus, let's say I. Okay. So if I have a complex rational number or a term which is kind of like this, in that case, how can I write this into this form, which is a plus ib? That is real and imaginary part. That could be another question for you based on complex numbers. So the idea here is to rationalize the denominator. So we'll rationalize, that is to say 2 plus 5i divided by 3 minus I, we need to multiply by 3 plus I and divide by 3 plus I, right? So that will help to rationalize. Now, so let's multiply the numerators. So in the numerator, we have 2 plus 5i times 3 plus I. So we'll expand as we did this expansion. And in the denominators, we have 3 minus I times 3 plus I. Is that okay? So let's expand. 2 times 3 is 6. And 2 times I will be plus 2i. Then we'll multiply by 5. 5 times 3 is 15. So we have 15i. And 5i times I is 5i squared. Since you know I squared is -1, I'll write this as minus 5. Is it okay? Now this is like a minus b times a plus b. So it is a squared, which is 9, minus b squared, which is minus I squared. And I squared, you know, is -1, right? So I squared is -1. Let's write minus I squared first. Okay. Let us simplify this. 6 minus 5 is 1. So we get 1 here. And 2 plus 15 is 17. So we have 17i in the numerator. Denominator, you know, I squared is -1. So it becomes 9 plus 1, which is 10. So now I could write this as 1 over 10 plus, this is 17 over 10i. You see that? So in this way, we have written the rational form of a complex number as a real part. This is the real part, right? And this is imaginary part. Is it okay? So rationalization helps us to do this operation. In most of the questions which are related to complex numbers for SAT preparation or similar type of tests, I think these concepts which are given in this video will help you a lot. You can see few other playlists on complex numbers which I have produced. They can help you practice. I'm Anil Kumar. You can always share and subscribe to my videos. Thank you and all the best.